Hello and welcome. All right, so here's your warm up from yesterday. And so hopefully you're checking your work from yesterday. And that would make sense to me. But Charlie got a new board game that came with the spinner shown. Complete the probability model for using the spinner. There's 1, 2, 3, 4, 5, 6 sections. 1, 2, 3, 4, 5, 6 sections. All right. There's a 2, there's a 3, there's a 4. There's a 6, there's a 7, there's a 9. What a weird game. All right. So complete the probability model. So for A, the probability model would be outcome probability. Then we would have 2, 3, 4, 6, 7, 9. Then if I'm looking at this, all of the sectors or sections are the same, appear to be the same. Therefore, there are 6 sections, and so probability would be 1 out of 6. And it would be 1 out of 6 for each of those. It would be 1 out of 6 for each of those because this has uniform probability. Let's see what the question says. Oh. Then B would say, what is the sum of the probabilities in the probability model? Well, I add these all together, and when I add I add the probabilities of all of the outcomes for an event, then I will always get 1 as my solution. I have everything there, so I should have 100% of the outcomes. Okay. Then, what is the probability that Charlie spins the spinner and gets an even number? So for C, I have even 1, 2, 3. It'll be 3 out of 6, which is the same as 1 out of 2, which is the same as 0.5, which is the same as 50%. Okay. All right, that was number 1. Number 2, use long division to convert each fraction to a decimal. Show all your work. Label each decimal as terminating or non-terminating. So for 2, part A, we have 5/6. Every fraction is a division. Every division is a fraction. Numerator divided by denominator. 6 can't go into 5, so I add the decimal point and add a 0 because 5.0 is the same as 5. Push the decimal point into my answer, and then pretend that's a 50. 6 fits into 50 without going over 8 times. 8 times 6 is 48. 50 minus 48 is 2. I can add a 0 until I'm blue in the face because 5 is the same as 5.0, which is the same as 5.00, and I can keep adding zeros until I don't need to anymore. 6 goes into 20 without going over 3 times. 3 times 6 is 18. 20 minus 18 is going to be 2. Add a 0, bring it down. 6 goes into 23 times. 3 times 6 is 18. 20 minus 18 is 2. Add a 0, bring it down. 6 goes into 20 3 times. 3 times 6 is 18. 20 minus 18 is going to be 2. Add a 0, bring it down. 6 goes into 20 without going 3 times. I'm waiting. Hopefully you said there, you're like, it's a repeating decimal. And so if I was answering this, it would be 0.83 repeated. The line should only go over the 3 because the 3 is what is repeating there. And then this is definitely a non-terminating decimal. Okay. Then for our second problem here, we have the wonderful 15 over 16. Every fraction is a division. Every division is a fraction. Numerator divided by denominator. I can add a decimal. I can add a 0 because 15 is the same as 15.0. And I can keep on adding zeros forever and ever. When I have a 2-digit divisor like that, I like to make it a little bit easier by listing the multiples of 16. So 16, 32, 8, 48, 14, 64, Let's see here, 10, 80. All right, 6, 96. 1, 2, 3, 4, 5, 6. 12, 1, 11, 112. Good. Let's see here. 8, 128. 1, 2, 3, 4, 5, 6, 7, 8. One more. And then we have 14, 3, 4. We have 144. Okay. And if I look at this problem here, 144 is my first winner. So I'm going to put 9 in. 9 times 16 is 144. I subtract. I have a 0. I bring it on down. I look. It goes in 3 times without going over. Ooh, decimal pushes straight up into my answer. I have to line up my numbers above that. 3 times 16 is 48. 60 minus 48 is going to be 12. I can add a 0. I can bring it down. 16 goes into 120 without going over. 1, 2, 3, 4, 5, 6, 7. 7 times. 7 times 16 is going to be 112. 120 minus 112 is 8. Add a 0. Bring it down. 16 goes into 80 without going over. 1, 2, 3, 4, 5 times. 5 times 16 is 80. 80 minus 80 is nothing, and so that is my answer. So I should get 0.9375. And when I'm looking at your work, I should have been seeing from your work that I see all of this that goes with it, so I can tell that you know how to do this at this juncture. All right, ladies and gentlemen, that was your warm up from yesterday. And now make sure you get your warm up done from today. La 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 la.